Students, in this class we will be studying about the hyperbola. Now let us first draw the hyperbola. So the x-axis is y-axis. The hyperbola is nothing but two parabolas fused. Okay, now this is one type of hyperbola we are going to be studying. So just as in the case of the parabola, we will have a focus and its coordinate is going to be a, 0, and a vertex is there, it is going to be a and its coordinate is going to be a, 0. Similarly, there is a vertex on the negative side which is a dash and it's going to be negative a, 0. This is the center. Okay, this is an hyperbola centered around or centered at 0, 0. Now, as in the case of the parabola, we will have a lattice rectum and that will be passing through the foci, okay, L dash. Now, similarly, let us have the focus on the left side. It's going to be S dash, negative a, 0, and let this be also drawn, say M and M dash. So this is the lattice rectum. Okay, maybe I can write it down here, lattice rectum. Okay, this entire line. Now what we are going to do is we are going to be dropping a perpendicular. Okay, in the normal case for a parabola, this would have been a directrix. Okay, so that is exactly what it is going to be in case of the hyperbola, but we will have to get certain things done before we bring that conclusion. Now we need to understand certain directions. So let this intersecting point be some z, and what I'm going to do, I'm going to take a point, say P. So I have got a point P of x, y. So we are going to be using the point later on. And having obtained this figure, the important deduction is AS divided by AZ will have a constant ratio called as E. Also A dash S divided by A dash Z will have a constant ratio E. So this E is called the eccentricity of the hyperbola, and the value of E is greater than 1 for the hyperbola. Okay, remember that for the hyperbola the value of E is greater than 1. So we have got the foci, we've got the vertices, we've got the directrix. So we've got these things, and now there is something we need to also get. Now if I were to connect the point P with S and a point of P with, say, some T, okay, then you will have to know. In fact, let me, instead of naming it as T, just to keep with the conventions, I will take it as M and I will change this to some Q and Q dash. Okay, just to keep the conventions that are being retained in the notes. So if I were to take this ratio, which is SP divided by PM, for a conic, by definition, okay, by definition of conic, SP over PM will be equal to E, and if we were to square this, we would get SP squared divided by PM squared is equal to E squared. This is what we get. Now moving on, if I were to write this as sp squared is equal to pm squared times e squared, then I would easily replace this relationship. Okay, we need sp, so sp, so that's going to be x negative ae of x negative ae raised to the power 2 positive, you see that I'm just applying the distance formula, y negative 0 raised to the power 2, okay, equal to pm squared is going to be this point, okay, and that is going to be x negative of a over e raised to the power 2. Of course there is a e squared here, so we have to have that e squared also. Okay, so this is going to be the relationship that we will have to solve. So what I'm going to do now is to group them with x squared terms and y squared terms. I need to expand them. So if I were to expand them, I would get x squared negative 2 times aex positive ae raised to the power 2 positive y squared is equal to, this is going to be x squared negative 2 times ae times x positive a squared e squared multiplied by e squared. So this is rewritten as x squared e squared negative 2a e times e squared times x positive a squared over e squared times e squared. So this is rewritten as x squared e squared negative 2 e gets cancelled here, aex e squared and e squared can be cancelled, giving me a squared. So this is what I'm getting. Now what I'm going to do on the left side, I'm going to rewrite the terms. So it's going to be x squared negative 2aex positive ae squared positive y squared. I'm going to rewrite that again, x squared negative 2aex positive ae squared positive y squared. Now 2aex on the left and 2aex on the right can be cancelled, leaving me with x squared positive y squared positive ae raised to the power 2 is equal to x squared e squared positive a squared. Now I'm going to bring this x squared to the left, so that means x squared negative x squared over e squared positive y squared and then positive a squared e squared. Now let me bring this a squared also to this. So if I bring everything on the right side, it's going to be 0. So let me see how to get this thing done. Now if I were to take x squared out, I get 1 negative e squared positive y squared positive. If I take a squared out, I would get e squared negative 1 is equal to 0. So this is what I'm getting. So what I will do is I will continue on this side. So I have got now x squared of 1 negative e squared positive y squared positive a squared of e squared minus 1 is equal to 0. Okay, so I'm trying to take or make this term e squared minus 1. So if I do that, I will have a negative sign. So negative of x squared. Okay, if I were to multiply everything by negative, so this is going to be, or in fact if I take this negative sign out, this is going to be e squared negative 1. Okay, that's better. So positive y squared positive a squared of e squared minus 1 is equal to 0. So if I were to take e squared minus 1, in fact I can rewrite this as keeping this term like this, y squared positive a squared of e squared minus 1. I want to move this to the right, so that's going to be x squared of e squared minus 1. And now I want to move this y squared to the other side, so it's going to be a squared of e squared minus 1 is equal to x squared of e squared minus 1 negative y squared. So this is what I've got. So now what I'm going to do, I'm going to divide by e squared minus 1 times a squared. So when I do that, I get a squared of e squared minus 1 divided by a squared of e squared minus 1 is equal to x squared times e squared minus 1 divided by a squared of e squared minus 1 negative y squared divided by a squared of e squared minus 1. Okay, this is what I've got. Now e squared minus 1, e squared minus 1, these terms are getting cancelled, giving me 1 is equal to x squared over a squared negative y squared divided by a squared of e squared minus 1. Now if we were to take setting a squared of e squared minus 1 is equal to b squared, if I were to take this and substitute in 2, so I'm using this page, okay, therefore 2 would be rewritten as x squared over a squared negative y squared over b squared is equal to 1. Okay, now this is the equation of hyperbola in standard form. Okay, of course I have already discussed with you the terms, the vertex, in fact let me write that down, the line segment, okay, AA dash has got a name, okay, in this case we call it as the transverse axis of length being 2a, okay, so that is critical. Now the line segment B dash is called the conjugate axis of length equal to 2b. Okay, now CA is equal to CA dash, and we call it as the semi-transverse axis, and its length is a. Now similarly CB is equal to CB dash, and we call it as the semi-conjugate axis, and we have the length as b. So these are some of the information that you will have to know. Now the equation of the directrix, okay, x is equal to a over e and x is equal to negative a over e are the two directrix of hyperbola. Now the lattice rectum. The length of lattice rectum, okay, is given to be as 2b squared divided by a. These are the following informations. Of course, the hyperbola will have an asymptote, and we will deal with that in the following classes.